Hi, welcome to today's lesson, part 2 of point-slope form of a linear equation. Okay, the last two lessons we spent a lot of time on slope-intercept form, which I think is still the most important. It is the easiest to read, it is easiest to graph, because it's always near the middle. I think it's the best. Okay, point-slope is great because it lets you branch out and become other forms. And it's not restricted by, I gotta be right there in the middle, because the point could be anywhere. Okay, and it ties back in with our slope formula, so it's something we've seen before. We're just utilizing it in a slightly different fashion. Okay, so we saw how to graph it. We saw how to pull it together. But the most common way you're going to be asked to write a linear equation in point-slope form is given 2 points. Okay, so they'll say write, and I'm saying write the at the same time, write the equation in point-slope form. And they may not even tell you to do it in a specific form, but we really want to get used to this form. It's a great form. Okay, they ask you to write it in point-slope form. They might ask you to write it in slope-intercept form. We're going to see that in a little bit later in this lesson, that this is a great way to get to that one. Okay, we saw how to do it in that lesson, but we're going to see another way that's maybe even a little easier. Okay, so write the equation in point-slope form of the line passing through the given points. And I'm just going to give you 2 points here. We're going to go like, 2, 3, and how about -1, 5. I don't know. That seems reasonable. I have no idea what that's even going to be. I didn't even try to make it easy on myself. I just picked small numbers so the math was easy and something I could do quickly. Well, in order to write an equation in point-slope form, I need 2 things, right? I need a point and I need a slope. Well, I got the point. In fact, I got 2 points, which is going to become a question to answer in a second here. But I have 2 points, so what do I need? I need a slope. Well, fortunately for us, we have a formula for finding the slope, and it was y2 minus y1 over x2 minus x1, and that's our slope. So we have 2 points, we can use them. So this is my x1 and my y1. This is my x2 and my y2. Okay, so 5 minus 3 over -1 minus 2. Well, 5 minus 3 is nice and easy. That's just 2. And a little queso, keeping the -1, switching this to addition, changing that to its opposite, gets me a -3. And I'm just gonna move the negative sign up to the numerator, because whenever we say a negative number, we would always say the negative, like the adjective, first. This is the fraction -2/3. It's not 2 -3rds. It doesn't make sense to say it that way, because it's like you're breaking up a compound word. Like birthday, you're saying this is like friend day, not my friend's birthday. It doesn't sound right. So we would move the denominator, we'd move the negative sign to the numerator, and then we would say it. So now I have a slope, and I actually have 2 points. Which one do I use? Well, if you kind of look at the formula has an x1 and a y1, so I would sort of lean towards that as my default. But you know what? It actually doesn't matter. Both are going to let me write an equation, and I'm going to use both. I'm going to do it one at a time. I'm going to get 2 completely separate equations. Okay, and this is where it sometimes gets a little confusing. So I'm going to say y minus 3 equals -2/3 times x minus -2. And I would clean that up. Sorry, I wouldn't say minus -2. What am I saying? Just say -2. -2, because it's a 2. And that's it. That's one possibility. I could use the other point. Y minus 5 equals still negative 2/3, same slope, x minus negative 1. And that one I will clean up. Y minus 5 equals negative 2/3 times x plus 1. Now I know many of you are probably saying, well, which equation's right? The answer is they're both right. Okay? One is not better than the other, one is not more correct than the other. However, if you're taking a multiple choice test, you might think I would like this to be the right answer, but they wrote it this way. So I need to know that it could be either of them. Okay? They're both completely legitimate, and there's not one that is better than the other. Now there may be one that's easier than the other because this one is both positive numbers, so I don't have to worry about the minus part happening. So it certainly, to me, strikes me as an easier one to utilize, and 2 and 3 are better, I think, than a 5 and a negative 1. Just again, for which numbers I get to use. So I have some decision making for my own sake on which one I want to use. You pick the one you want. It doesn't matter. I would say for most arguments, stick with something and be consistent. I would just say, you know what, this is x1 and this is y1, and the formula has x1 and y1 in it. I'm going to use those. But I'm going to show you one big overarching using either in just a second. Okay? Because why do we like this form? Well, if I have a point and I have a slope, it's really easy to get. Okay? It's easy to get into, it's easy to utilize. But what if I were asked to write the equation in, so here I'm going to erase all this. What if I were asked to write it in, not point slope form, but slope-intercept form? This is the one we remember, that's the y equals mx plus b. This is our favorite form. It's the easiest to read. It's the easiest to graph. Okay? A person can just see the equation and know what the graph looks like. They can see the graph and know what the equation looks like. But what if I were asked to write it in that form, and they said, so write the equation in slope-intercept form of the line passing through the given points. So we're going to do the same situation where I'm going to give us 2 points, and we're going to use those 2 points to create an equation of a line in y equals mx plus b. Now we saw, I find the slope and then I use one of the 2 points to figure out what the y-intercept was. But I'm going to show us a different way to do that right now. So let's get our 2 points. How about, let's go 4, 1, and 2, 3. Let's make it easy on myself. Okay? That should be nice and easy. So first I need to find the slope, okay? Because slope-intercept form, I don't see the intercept because I don't see where the x is 0, so I don't have the intercept. I need to find the slope, so that's the first thing I'm going to do. So slope is 3 minus 1 over 2 minus 4. y2 minus y1 over x2 minus x1. 3 minus 1 is 2, 2 minus 4 is negative 2, and 2 divided by negative 2 is negative 1. So there's the first part. Got my slope. Okay? Now, here's where point slope form really has a great use. I'm not going to try to use this and this point to figure this out by plugging it in and then solving like we did in the last example, in the last lesson, like last week. I'm going to use this and this to put it into point slope form, and then I'm going to get it out of that form. You watch. So here we go. So y minus, we're just going to grab the very first point here, 1 equals negative 1 times x minus 4. So now I've written the equation in point slope form. Why do I do that? Because now it's 2 steps to get it into slope-intercept form. And it's always going to be the same 2 steps unless one of the steps is already done for us, like if one of them was 0. First step is going to be to do the distributive property. So y minus 1, nothing's changing over here. Negative 1 times x is negative 1x. Negative 1 times negative 4 is positive 4. You can see I've almost got it in y equals mx plus b. The only thing is, what's about this -1? I'm going to add it. I'm going to get rid of it. Y equals -1x plus 5. And I will even neaten this up just a tiny bit by dropping the 1 and just saying -x plus 5. Okay, that is how we change from point slope form to slope-intercept form. And that's why we like it, because now you can give me any 2 points. I can just go, here's the slope, that point in the slope, and figure out where it hit the y-axis. If I were to graph this, I don't have to guess anymore. I know it hits the y-axis at 5. Okay? In fact, I'm going to draw that at the top here. So if I were to plot the 2 points were, oh, I shouldn't have erased the points, I guess. They were 4, 1, and 2, 3. So 4, 1, 1, 2, 3, 4, 1 is right here. And 2, 3 is right here. I can see it's a negative slope because it's going down, and it's going to hit right up there at 5, just like I knew it would. Okay? Now, the other thing I can do here, remember I said it doesn't matter. We had 2 points. What if I had used the other point? What if I'd used the 2, 3? Would that have changed? Would that change anything? And the answer should be no, because we already know where it hits the y-axis if I connect those 2 dots. And I'm basically asking, hey, you other point, where do you hit the y-axis if I connect you to the first point? And they both should tell me the same thing, because that's the way this works. So if I take my slope of -1 and my other point, 2, 3, and I do the exact same process, y minus 3 equals -1 times x minus 2, I have now written a completely different looking equation than the first one that I wrote in point slope form. But when I solve it, which I will solve in exactly the same fashion, I'm going to do the distributive property, and then I'm going to get rid of this. So let's do that first. Do the distributive property. So y minus 3 equals -1. -1 times -2 is +2. And then I'm going to add 3 to both sides, and look what happens. Y equals -1x plus 5. And we knew that. -1 slope, y-intercept of 5. Okay? So point slope form is a great form to get a quick linear equation with, because you can use either of the 2 points. They love to do this. They love to say, write the equation of the line passing through the given points. They give you 2 points, and this is true in your real life. If you're, hey, I'm trying to figure out from this point to that point, trajectory. Maybe you're trying to launch a missile or shoot a bullet or figure out where a bullet's already been fired. If you're into those like CSI shows where you're like, well, you must have been on that rooftop. Because that's what they're doing. They're going, hey, I have a point here where it hit the wall, and I have a point here where it hit the floor, and based on those 2 points, I can create a trajectory and figure out where the shooter had to be standing. Because I can figure out where hey, you know what my y-intercept is? It's that building over there. Where does it hit? Where would that person have to have been in that building? Were they on the roof? Were they on the 6th floor? The 16th floor? I can figure that out by connecting these 2 points in real space. Okay, could be, again, air traffic controller. I want to make sure these 2 planes don't collide. I have one plane doing this, I have one plane doing that. Let's make sure we're, this plane is trying to go from here and land. That's going to create this trajectory. How does that work? And so on. And then, so this is the great form to just jump right in. Hey, I already got the 2 points. All I need is the slope. As soon as I have the slope, boom, I can write the equation. Okay, if I want to then figure out the y-intercept, I have some steps to do. If I don't want to, I don't have to. Okay, if it just asks for point slope, I stop here at point slope. I'd say the hardest thing is remembering that when you're reading point slope form and you're trying to go from a graph, for example, back to point slope, that you want you're looking at like the opposite of what you see here. So this -2 is because this is 2 is positive. This -3 is because this 3 is positive, and vice versa. If it were negative, if this were a plus sign, then those numbers would be negative. Okay? All right. Point slope form, great form, really usable, helps us get into Slope-Intercept, and from there we're going to go to standard form. That'll be next week. And I hope this was helpful. And as I step forward to turn off the video and welcome you back, you can see my adorable kitten. There she is, asleep in her little tree.